Hello everyone, welcome back to another MCR3U video. We are continuing sinusoidal functions, and today in this lesson on section 6.5 we are using the transformations we learned in the last video to sketch the graphs of sinusoidal functions. Here's the chapter outline, and you can find some more practice with sketching sinusoidal functions using transformations on pages 383 to 385. Our success criteria is simple for this lesson. We want to just sketch the graphs of sinusoidal functions using transformations, and we want to understand how each transformation changes the properties of the sinusoidal graphs. So let's get to sketching. Okay, let's look at our first example here. This example, the solution is already written out for you on the page, so I'll kind of just go over it and explain how this specific question was solved, and in the next two examples I'll actually draw it with you and do the actual example. So this example says sketch the graph of f of x equals 3 times sine of 2 times x minus 60 degrees plus 4. So we have a sine function. Our a value will be 3, our k value will be 2, our d value will be 60, positive 60, remember, because this negative sign is there in the original formula with all the variables, and our c value is 4. Okay, so just keep that in mind. And there's 5 steps in using this method of sketching a graph. The next two examples will be using a different method, but for this one, we use this method that involves these 5 steps. First step, we want to sketch the original graph of f of x equals sine of x, and that is exactly this green graph that we have on the left. Of course, again, we're starting at 0, we're going up to 1 at 90 degrees, we're going back down to 0 at 180 degrees, down to -1 at 270 degrees, back down to to 0 at 360 degrees. Okay, so we want to just sketch out that first original graph and go from there. Step number 2, we want to sketch our first transformation, being our horizontal stretch / compression, and in this case we have k equals 2, so we're going to have a horizontal compression by a factor of 1/2, because remember, if k is greater than 1, we're going to have a compression by a factor of 1 over the absolute value of k, so 1 over 2. Okay, so we're going to have a horizontal stretch by a factor of 1 over 2, and our period will be 360 divided by the absolute value of k. In this case, k equals 2, so our new period will be 180 degrees. So if we sketch out this new graph here on step number 2, it will be the pink graph, which you can see is a compressed version of the green graph, right? We're compressing it by the sides, and we're kind of pushing it in halfway to what it originally was. So if you notice, all the points are halved. So, sorry, the x values are halved, not the y values. So with the pink graph, this point right here is 90, and that original point on the green graph was 180. So we're halving 180 to 90. This point, let's say this point right here was 90, looks like, and we half that point to 45. We can keep going. This point is 270. If we half that, we get 135, and so on. So we're compressing that graph inwards and applying that first transformation. And as you can tell, our new period is 180, because this is one cycle of our graph. All these drawings are just one cycle of our sine graph, and our period for the pink graph is 180 degrees. Next, step 3, we want to graph our second transformation. So we want to graph f of x equals sine of 2 times x minus 60 now. So we want to apply the horizontal translation 60 units to the right. So we are simply taking this pink graph, and we want to, let me pick a color here, I'll just use red. we want to, or black, we want to shift this pink graph 60 degrees to the right until we hit that blue graph, right? We're shifting all the points 60 degrees to the right. So this beginning point right here at 0 will shift to 60. This point at 45 will shift to 105. Let's say this point right here at, I think that's 90, will shift to 135, and so on. We're just shifting 60 units right until, and we get that blue graph for step number 3. Then moving on to step number 4, which is down here now, we want to graph f of x equals 3. So our new transformation is going to be our vertical stretch times sine of everything else we had before. So again, we have a vertical stretch by a factor of 3, because remember, if the absolute value of a is greater than 1, we're going to have a vertical stretch by a factor of a, and a is 3. So going from our blue graph, right, to our purple graph, it looks like the blue graph is more stretched out, but that's because our graph B is expanded out more. So as you can see, here we only go up to 1, here we go up to 7. So we can tell that this graph has been stretched from graph 3 to graph 4, because if we notice, our point here was at y equals 1, and our point here now is at y equals 3. We're multiplying all the points on our graph by 3 to vertically stretch it. Down here, it was at -1, our blue graph. Down here is at -3, and so on. Every point on the graph has been stretched, and we're kind of stretching this graph, this blue graph, outwards like this to get this purple graph. Okay? And the last transformation we want to apply is our vertical translation 4 units up, which we represent with our +4 here at the end, our C value. And we simply just want to take our purple graph and move it up 4 units. Right? So every point on our purple graph, we just want to add 4 to that, and we get our final graph, which is graph number 5. Right? So here we had a point at 0, here we had a point at 4, here we have a point at 3. If we move it up 4, we have a point at 7. Here we had a point at -3. If we move it up 4, we have a point at 1, and so on for every point on the graph. And our equation of the axis will change to our C value. So originally it was at 0, y equals 0. This is our original equation of the axis. And if we move up, our new equation of the axis is at y equals 4. Right? Because remember, our equation of the axis will become our C value. Okay? And that is it for our first example. Okay, so moving on to question number 2. And this question, we will use a little bit of a different approach and method to solve the question. Now we have table of values that we are going to use to solve this question, instead of going step by step and drawing each graph. So the question says graph y equals -2 cosine of 3x minus 1, and state the amplitude period equation of the axis. Phase shift, which is a new term we haven't learned, but it just means the horizontal shift or horizontal translation, and range of this sinusoidal function. Okay, so let's use the table of values. In the first table of values, we want to plug in the values of f of x equals cos of x, our original function, and in the second one, or y, and in the second one, we want to plug in the values of our transformed function, 3x minus 1. So let's do our original first. So cosine of x, we can start with, let's say, -180, and then go -90. Well, should we start with negative? Yeah, sure. We'll start with -270. Then we'll go -180, then -90, 0, 90, 180, 270, the main point in our graph. Okay, so our y value for cosine, we can start at 1 because we know that at 1 we're going to have a 1, right? Because our cosine function is going to go like this. It's going to start up here. If we go down to 90, it's going to be -1. We should actually do 45s between each one. So we'll do 0, 45 degrees, 90 degrees, 135 degrees, 180 degrees, -45 degrees, and then 90 degrees. That'll be fine. So again, 0, we start at 1. If we plug in an x value of 0 to our original graph, we'll get a 1. Then if we plug in a 45, we'll get 0. Oh no, sorry, I'm wrong. Okay, it was right the first time. So we'll go 0 here, then 90, 180, 270, then -90, -180, -270. Okay, here we go. So we're starting at 1, and then at 90 is when we're at 0. Then we go to -1 at 180, and then back to 0 at 270. And if we go back, we go to 0, -1, and then 0. Okay, so that's our table of values for our original graph. Now, if we apply our transformations, we want to multiply the x values of our original function by 1/3 because we have a k value of 3, which is greater than 1, meaning we're going to have a compression by a factor of 1 over absolute value of k, which is 1/3. If we have a compression by a factor of 1/3, we want to multiply all the x values by 1/3 to compress the graph inwards. From the left and from the right, we kind of push it in, okay? So for the y value, we want to multiply it by -2y. Sorry, we want to multiply y by -2 and then subtract 1 because, again, we have a vertical stretch by a factor of 2. We're reflecting along the x-axis, so all our positive y values are going to become negative, all our negative y values are going to become positive, so that's why we have this negative sign here, and we're going to subtract 1 because we have to translate the whole graph down 1. So we subtract 1 from all the y values, okay? So if we apply these transformations to our points from our original graph, we'll get the new graph. So if we multiply the x values here by 1/3, we'll get -270 times 1/3 will give us -90. Now -180 times 1/3 get us -60 degrees, and -90 divided by 1/3 will get us -30 degrees. Then we'll get 0, then we'll get 30 again. 180 times 1/3 is 60 degrees. 180 times 270 degrees will get us 90 degrees. Okay, that's it for our x values. For our y values, we want to multiply -2 times our original y value, then -1. So -2 times 0 is 0, -1 is just -1. Then if we, I'll do a couple of these just so you can see what I'm doing. Next one, we're doing this row. So we're going to have -2 times -1 minus 1, which equals 2 minus 1, which is just 1. Next, we're going to have -2 times 0 again, minus 1. It's going to give us -1. Next, 1 times -2 minus 1, it's going to give us -3. Then we'll get -1. Then we'll get 1 again. And then the last one will get -1. Okay? So, from these points, we can graph our function. We can just plug them in and kind of sketch our curve. So, at -90, we are at -1. So, we'll say this is -1. This is, actually, no, we can't because we have to go to -3. So, this is -1, -2, -3, -4. And then 1, 2, 3, 4. Okay, so at -90, we're at -1. And I'll actually do this in black, -1. At -60, which is, let's say, if that's -90, then say this is -60, and this is negative 30, right? Or maybe here. So at negative 60, we are at about, we're at 1, sorry. And then at negative 30, which is kind of around here, we are at negative 1. Then at 0, we're at negative 3. Then at 30, we're at negative 1. So 30 again is around here. Then at 60, we're at 1. 60 is around here. And then at 90, we're back to negative 1. So from here, we can draw a cycle and a half of our function. But if we actually keep going, and I'll show you, but let's just sketch going around the points we have. And like this, we can sketch our new function with our transformations applied. And if we want to see it compared to our original function, we just do like this. So we start our cosine here, we go like this, something like that. And if we go back, something like that. Okay? So you can see that the graph has been compressed horizontally. We have reflected it along the x-axis. We have brought it down 1, and we have vertically stretched it by a factor of 2. So now that we have the graph, and we can even draw a few more points in if you want, but we can just leave it like this. We can go down here and come and say this is negative 3, and then back up, and then here, and we can keep going, but this is just fine. Oh, I erased the other graph. Let me just put it back. Okay, now the question asks us to find all the properties. So let's first start with amplitude. The amplitude, as we know, is just going to be our a value, our absolute value of our a, which is going to be 2. And as we can see from the middle of the graph, which is here, right here, of our new graph, oh, this cosine graph is drawn very wrong. We're going from 1 down to 90, down to negative 1, which is here, not down there. Like that. Okay, it did look weird to me. Okay, like that. Okay, kind of like that, and I think this is wrong too. Just like that. Okay, we'll leave it there. Okay, so our amplitude is 2 because our center line is here at y equals negative 1. And we're going up 2 to get to our peaks, down 2 to get to our rows. So our amplitude is 2. Our period will be, let's say, 1 cycle. So let's say from here to here, which we're going at this point, this is negative 60 and 1. So we're going from negative 60 to, that's positive 60. So that distance altogether, it's 120 degrees. And it makes sense because our period, if you guys remember, will be 360 divided by the absolute value of k, which is 3. So our period will be 120 degrees. Period equals 120. Okay. Next, we have the equation of axis. This is going to be our max value, which is 1, plus our minimum value, which is negative 3. We're going to divide that by 2. And so 1 minus 3 is negative 2, divided by 2 is negative 1. Therefore, our equation of axis is y equals negative 1. Okay? And then it wants the phase shift and the range. So the phase shift, it's simply the horizontal shift. And in this case, we have no horizontal shift in our question, no d value. So therefore, we can say, therefore, no phase shift. Okay. And lastly, it wants the range of the function. So I'll write the range over here. I'm kind of all over the place, but I'm just boxing in the answers. I should actually box this one in as well. The boxed in answers are the answers to our question. So range is going to be f of x is greater or equal to 1, which is our max value, or sorry, greater or equal to -3, which is our minimum value, and less or equal to 1, which is our max value. Or we can say instead of f of x, y. That's our range, and that's the end of our question. Okay, and that is it for the video, guys. Thank you so much for watching. I hope you were able to understand everything well, and how we apply these transformations to sketch these new graphs. And make sure you get some more practice, as I know this video wasn't long enough to kind of cover all the little things you may have to go through when sketching these graphs. So make sure you practice, and I'll see you in the next one.